let's perform partial fraction decomposition to this rational function. Notice the degree of the numerator is degree 2. Degree of the denominator is degree 3. So 2 is less than 3. And so we do not have to perform long division here. In fact, we just need to make sure we see factors in the denominator. And we do. We do have factors in the denominator. It's actually x plus 3 is linear with multiplicity of 3. Okay, so off to the side is where I usually show most of my work here. And how do we decompose a linear factor with multiplicity? Well, the algorithm is fairly simple. We're going to write a constant for every single linear factor. So the first linear factor is x plus 3. The second linear factor is still x plus 3, but it has multiplicity of 2. And the third fraction is going to have a c, and the linear factor is now x plus 3 with multiplicity of 3. And now we're ready to solve for our a, b's, and c's. So if you multiply the equation by the common denominator, the least common denominator, we get a times x plus 3 squared plus a b times x plus 3, and then plus a c. Since we do have a linear factor, it makes sense to test this triple star equation. So why don't we test, let's say x equals -3. And what happens to that triple star equation? Well, we get 45 minus 3 is 42. 42 plus 8 is 50. Is now equal to, we got 0 times a, we got 0 times b, and so we actually just have c. C is 50. Wow, that's kind of nice. Now, why don't we write a different equation? And let's call this equation triple triangle. So we have 5x squared plus x plus 8 is now equal to, why don't we do something like this? Why don't we do ax squared plus 6ax plus 9a plus now what? A bx plus a 3b plus ac. So why is this useful? Well, we could actually see what a is. We could match the coefficient of x squared with the coefficient of x squared here. That tells us that a is equal to 5. Awesome. Now there's only one letter left to solve for, and that would be b. So how can we solve for b? Well, let's look at the coefficients in front of the x. So 6a plus 6b, 6a plus b must be equal to the invisible 1. What do you mean the invisible 1? There it is. The invisible 1 is now visible. Let's get b. So b equals 1 minus 6a. So b must be -29. Do we have everybody? Yeah, we do. So let's finalize our answer. Let's break this one big fraction into little fractions. So A was 5 over x plus 3 plus B, well, minus B then, minus 29 over x plus 3 quantities squared, okay, and then plus 50 over the linear factor of x plus 3 with multiplicity of 3. And there you go. We have performed a partial fraction decomposition with a linear factor with multiplicity.